In this next tutorial, we will be finding the equations, this time of our horizontal asymptotes, and continuing to talk about intercepts, domain, and range. So let's flip over to this page of our notes. Horizontal asymptotes are a little bit more complicated to find than the vertical asymptotes. Horizontal asymptotes, you must first understand what the degree is for the numerator and for the denominator. And then there are these three cases for you to determine which one is which. If the numerator's degree is something that is less than the denominator's degree, then your horizontal asymptote will always be y equals 0, the equation of the x-axis. If your numerator's degree is exactly the same as the denominator's degree, then you will take y equals the leading coefficient. There's a leading coefficient in the numerator and in the denominator. Y equals that main leading coefficient would be your horizontal asymptote there. And the final case, if the numerator happens to have a degree that's bigger, greater than the denominator, then there is no horizontal asymptote. But like we're going to see in our next tutorial, maybe in this case, there's a slant asymptote. We'll talk about that in the next tutorial. So I have d of x, e of x, and f of x to explore our horizontal asymptotes. First, let's talk about vertical since we just came out of that. All three of these denominators are identical, 3x squared plus 1. I hope when you realize that when you try to set this equal to 0 that there's no way that this could happen. Squaring is positive, multiplying by 3 is even more positive, and adding 1 is even more positive. There are no vertical asymptotes for all three of these. So none here, and none here. This exploration is just for our horizontal asymptotes. So let's look at d of x and let's talk about the degrees, because that's what we need to do for our horizontal asymptotes. The degree of the numerator in d of x is 1. That's a little exponent here. And the degree in the denominator is 2. So clearly this is case 1. Since the numerator's degree is less, I know that it's going to be y equals 0. So I'll dash that in, y equals 0. We can continue to review the x-intercepts and the y-intercepts. X-intercepts always come from the numerator equaling 0, and 2 times 0 would be equal to 0, so it makes sense that our x-intercept is 0. And if our x-intercept is 0, then our y-intercept, of course, would also be 0. And you can prove that. So I'll put a blue and a pink dot there. So just because I want to show you what the graphs actually look like, I'm going to sketch a quick graph of what this one does. Again, that's not so important right now. We'll talk about that later. And you can see we actually cross right through an asymptote in this case. Sometimes we'll cross right through a horizontal asymptote. That's fine. E of x. We've already done the vertical asymptote. Let's talk horizontal asymptote. In E of x, I've increased the numerator's degree this time to a 2. So therefore, the degrees are identical. And if the degrees are identical, we take the leading coefficient. The leading coefficient in the numerator is 2. The leading coefficient in the denominator is 3. So the overall leading coefficient is 2/3. And y will equal 2/3 for our horizontal asymptote. So here's our tick mark of 1, and I'm going to go just a little bit shy of that to make y equals 2/3 my horizontal asymptote. X-intercept and y-intercept are identical because we still set this equal to 0, and x is still going to be 0, and y is still going to be 0. So we can plot those right here. And like I said, just because I want to show you what the graph looks like, this one, you gotta kind of tuck it in there. Kind of looks like a bird. And there we go. Finally, f of x. We've already done the vertical asymptote. This time, let's talk about the horizontal asymptote. And now I've increased the numerator to a degree of 3. And since that makes 3 greater than 2, we are in our third case where there is no horizontal asymptote. So we don't have any asymptotes for this one. The x-intercept and the y-intercept are still 0 and 0, because you set the numerator equal to 0 and you still get a 0. And if we're crossing the origin for the x-intercept, of course we're crossing the origin for the y-intercept. There's no other way that that can happen. So let's see if I can graph this one. This is actually a tricky one. This is actually a graph that has a slant asymptote, but since we don't know what slant asymptotes are yet, I'm not going to draw it in. So it's always tricky for me, but that's not too bad. Again, it's not important about the graphs right now. We'll look at that at a future tutorial. So this was all about finding horizontal asymptotes, and it depends on those three cases. If we go back to A of x, B of x, and C of x, we can now understand why our horizontal asymptotes were what they were. A of x, the degree of each of these were 1. So therefore, it's that middle case where we take the leading coefficient. And the leading coefficient here is 2 divided by 1. That's why y equals 2 was our horizontal asymptote. In our b of x and c of x, the degree in the numerator is 0 here, because this is like 4x to the 0 power. And 0 here, this is 2x to the 0 power. 0 is less than the denominator's degree in both cases, and that's why case 1 is what the horizontal asymptote is, y equals 0 and y equals 0. So make sure you understand those three cases, and I'll see you in class to practice that.